All right, listen up, agents. Welcome to your mission briefing. Today, we are initiating a massive exam extraction protocol. You are a secret agent, and your primary target, your mission, should you choose to accept it, is to extract maximum marks from a highly hostile Cambridge computer science pass paper in 20 minutes or less. We are specifically targeting the Cambridge AS and A-Level 9618 syllabus, but the extraction strategies we're decoding today are absolute game changers, whether you're tackling 0417, 0478, 0983, 0984, or 2210. Now, to do this, we're unlocking one of the most notoriously rigorous sections of the entire paper, the Database Management System Query Processor. Imagine you're sitting in that exam hall, the clock is ticking down, the pressure is on, and you are staring at a massive 12-mark question. I want you to picture two candidates. First, we have Alex. Alex is the kind of student who overloads every single answer with raw, unfiltered computer science facts. They just dump every textbook definition they've ever memorized onto the page, but there's absolutely zero analysis. Then, we have Sam. Sam is incredibly smart but constantly rushes. Sam completely misses the specific command word requirements and just writes down the first thing that comes to mind. By the end of this explainer, you are going to see exactly why both Alex and Sam end up with their papers covered in red ink, and more importantly, how you are going to avoid their fate.
Now, why are we focusing so heavily on the query processor today? Because we managed to intercept a direct piece of intel from senior examiners. They explicitly noted that the difference between a B and an A star in computer science often comes down to how well you understand this exact topic. Let that sink in for a second. This isn't just another bullet point on the syllabus. This is the gatekeeper to the top grades. Why? Because it tests everything all at once. It tests your deep theoretical knowledge, your algorithmic thinking, your logic, and your ability to evaluate complex multi-step systems. It is literally the ultimate proving ground for a computer science student. If you can master the query processor, you prove to the examiner that you don't just know how to code, but you understand how the machine actually thinks and processes data under the hood.
So here is our highly structured tactical roadmap for today's extraction. 1. Core principles and architecture. 2. The procedural framework. 3. Top examiner warnings. And 4. Evaluation and critical analysis. Let's get moving.
Section 1. Core Principles and Architecture. Okay, we have to start by building an absolutely bulletproof foundation. You cannot solve a complex database extraction problem without rock-solid theory. But here is where candidate Alex always goes wrong. Alex thinks that just giving a precise definition is enough. It's not. The theoretical architecture of the query processor does not sit in a vacuum. It rests on 3 critical pillars. Yes, you need precise definitions, but you also need to understand causal relationships. What causes the optimizer to choose one path over another? And the third pillar, this is the secret weapon, the absolute key to unlocking the A-star, is integration with other syllabus areas. Principal examiner reports continually highlight that candidates who reference cross-topic connections achieve significantly higher marks. You need to show the examiner how the query processor interacts with data structures, how it utilizes operating system resources for memory management, or how it relies on network protocols if it's a distributed database. It's like a giant puzzle, and you have to show them how all the pieces interlock.
To pull this off, you need to understand the minds of the people marking your paper. When examiners read your answers, they are scanning for 3 distinct cognitive domains: knowledge and understanding, application, and analysis. And this brings us to the ultimate decoding strategy for command words. If a question says state, that's just knowledge. But if it says explain or evaluate, you are in the application and analysis domains. This is where we deploy the Peel framework: point, evidence, explanation, link. Top-tier computer science students structure their answers by first making a clear point, providing evidence from the scenario, explaining the technical computer science principle behind it, and finally linking it back to the overarching system. It is a foolproof matrix from maximum marks. Now, before we dive into exactly how to apply this framework step by step, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you do not want to miss the advanced tactics we drop every single week.
Let's move to Section 2, the procedural framework.
This is where we unpack the method mark strategy. You see, Sam, our second candidate, always loses marks here because Sam rushes to the final answer. But examiners don't just want the answer. They want to see the procedural framework. They want to see your footprints. We use a standardized 5-step sequence that guarantees you capture every single available process mark. Step 1, identify the key elements from the given scenario. Step 2, apply the relevant DBMS principles to those elements. Step 3, execute your analysis with clear, step-by-step documented working. Step 4, verify your results. Think of this as a built-in sanity check. And step 5, present it all in the correct format with the proper, highly specific terminology. If you skip straight to step 5, you are leaving massive amounts of marks on the table. The process is where the method marks live. If your logical sequence is invisible to the examiner, your marks will be too. It is that simple.
Drilling even deeper into that procedural framework, practical application demands intense algorithmic thinking. When a query is parsed, optimized, and executed, it's essentially an algorithm running in real time. You have to explain that algorithm with absolute precision. This means demonstrating step-by-step decomposition. You have to break the query down just like the DBMS does. Lexical analysis, syntax parsing, semantic analysis, building the query tree, generating the execution plan. You also need to demonstrate appropriate data structure selection. Why use a B-tree index over a hash table in a specific scenario? You need to discuss efficient code implementation and have a rock-solid plan for rigorous testing. You are essentially reverse engineering the database engine on paper. You take the raw marks and you transform them into green check marks by proving you understand the exact mechanics of the system.
Section 3. Top examiner warnings. This is the classified intel. Now, for the insider access, we have analyzed the principal examiner reports, and we have identified the exact traps where even strong candidates unexpectedly blow their cover and lose marks. Trap number 1, confusing cause and effect. Examiners report that students frequently mix up the chronological and logical sequence within the query processor. For instance, candidate Sam might rush and describe query optimization happening before the SQL syntax is even parsed, or they might completely confuse the role of the DDL compiler with the query execution engine. You cannot optimize a query if you haven't validated that the tables actually exist in the data dictionary first, right? You must know exactly what triggers what in the processing pipeline. It is a strict chronological flow, and mixing up the timeline is an instant red flag to an examiner.
Trap number 2 on our hit list is forgetting boundary conditions. When you are asked to test or evaluate a query process, it is remarkably common for students to only describe the happy path. You know, what happens when everything works perfectly, the data is clean, and the server is fast. But examiners want to see that you understand edge cases. The real world is messy. What happens if the query tries to access a null value? What if the specific table being queried is currently locked by another transaction? What if the network drops during a distributed join? If your answer doesn't mention how the DBMS handles these boundaries and exceptions, you are putting a hard ceiling on your grade. Always, always check the boundaries.
And that brings us to trap number 3, which is frankly the most classic, heartbreaking error of all, ignoring context. Examiners explicitly flag this as a major examiner alert every single year. Students like Alex will memorize brilliant, beautiful textbook definitions of a query processor. They can recite the exact function of a query optimizer. But then, they write down a generic answer that is entirely disconnected from the specific scenario given in the exam paper. The examiner gives them a scenario about a global banking system, and the student writes an answer about a generic database. Stop right there. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's launch into an interactive workshop right now to show you exactly how to fix this context problem. I want you to mentally put 60 seconds on the clock. Picture a generic answer. It lists isolated facts. It accurately describes query parsing, sure, but it completely ignores the prompt. Now look at a context-linked answer. It takes those exact same facts but applies them directly. If the exam question is about a busy hospital database managing critical patient records during an emergency, your answer must explicitly link the query processor's actions to retrieving those specific patient records efficiently. You don't just say the optimizer chooses the fastest route, you say the heuristic optimizer utilizes the patient ID index to instantly bypass sequential scanning, ensuring life-saving medical history is retrieved within milliseconds. Do you see the difference? One is reciting a textbook, the other is solving a real-world problem.
If you had 30 seconds right now to write a perfect paragraph, you would use that Peel framework we discussed earlier to guarantee every single sentence links back to the hospital. Always link to the given scenario.
Section 4. Evaluation and critical analysis.
For our final extraction phase, we shift from simply identifying mistakes to mastering the higher-order critical analysis that securely locks in the A-star. Top-scoring candidates demonstrate what we call evaluative thinking. This means you don't just provide one answer, you consider multiple solutions. If there are two ways a query could be optimized, say heuristic optimization versus cost-based optimization, you must discuss both. You analyze the trade-offs. Maybe the cost-based optimizer finds a better execution plan, but it takes more CPU cycles to calculate that plan initially. You have to acknowledge the limitations of your proposed solution. Nothing in computer science is perfect. And above all, you must justify your final decisions with hard evidence extracted directly from the scenario. If you can argue the pros and cons like a senior database administrator, the examiner has no choice but to award you top marks.
So here is your ultimate cheat sheet recap. The complete computer science answering system comes down to 3 phases: deconstruct, solve, evaluate. First, you deconstruct the given information. You decode the command words and break the scenario down into logical steps. Next, you solve. You systematically process that data using the Peel framework and your deep knowledge of the DBMS. Finally, you evaluate. You check your outcomes for reasonableness. You look at the time management matrix to ensure you haven't spent 20 minutes on a 4-mark question, and you make justified recommendations. If you structure your longer exam answers around this sequence, deconstruct, solve, evaluate, you are directly answering the higher order assessment objectives every single time. You are effectively hacking the mark scheme.
To lock this entire framework into your brain, I have a final challenge for you. I want you to create your own unique mnemonic using the first letters of the query processing sequence: parsing, optimization, execution. But beyond memory tricks, remember this core truth. The query processor is the literal brain of the database, and the examiner is testing your brain's ability to mirror its logic and efficiency. Are you just memorizing facts, like candidate Alex? Or are you truly optimizing your approach to every single question? Students who implement these exact computer science strategies see an average improvement of 2 whole grade boundaries. But that only happens if they practice consistently with our weekly tactical breakdowns. So here's your final reminder. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to @AC Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the absolutely biggest challenge you're currently facing. Our team responds to every single comment to help you out. Hit the like button, share this explainer with your study partner, and remember, Ace the Exams. Your Cambridge success starts here. Mission accomplished, agents. See you in the next one.